We'll look at another example. Let's say I have a series from n equals 1 to infinity of n to the n over n factorial. So for this, we'll take the limit as n goes to infinity of n plus 1 raised to the n plus 1 over n plus 1 factorial. This is all under the absolute value over n to the n over n factorial. And so this will give us the limit as n goes to infinity of n plus 1 to the n times n plus 1 over n plus 1 factorial. And so n plus 1 factorial, we're simplifying n plus 1 times n factorial. Well, let me just, as an aside here, talk about that. N plus 1 factorial is going to be n plus 1 and then n factorial. And think of it this way. If we had 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. And so 7 factorial, which would be 6 plus 1, 7 factorial is just going to be 7 and then times 6 times 5 times 4 times 3 times 2 times 1, or just 7 times 6 factorial. And so that's where I'm getting this n plus 1 times n factorial. And then we'll multiply that by n factorial times n to the n. And so we take the limit as n goes to infinity. These n plus 1s are going to simplify out, and the n factorials will simplify out, and we'll have n plus 1 to the n over n to the n in the absolute value. So we can write this as the limit as n goes to infinity of n plus 1 over n to the n. And we can further simplify that as the limit as n goes to infinity of 1 plus 1 over n to the n. And we've done that limit before. That limit equals e, which is greater than 1. And by the ratio test, this series diverges.